Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be doing a demonstration of HSS. HSS is the high-speed surface machining module for smooth and powerful machining of localized surface areas in the part, including undercuts. We'll start off with this part that we see on our screen, and what we would like to do here is actually machine this particular surface over here. Now, it should be noted that this surface, as you see it, has breaks in between. It has this slot in between over here. Also have these holes. Now, if I would have to do this in our regular operations, I'd have to first plug up these holes, whether build another solid over there. But in HSS, we have the tools that can actually just simply glide directly over those slots without even noticing that there was a slot there in the first place. We'll start our operation and we'll choose the option of HSS. Now, in HSS, we'll choose the option in this particular case, parallel cuts with constant Z. In other words, I'll be doing parallel cuts on the surface itself in the constant Z fashion. Now, in my geometry area, I'll be choosing my selected faces, which are these faces over here, as I had mentioned before. And my tool that I will be using will be a 10mm bullnose mill. Now, in my levels area, I'll leave it exactly the way it is without making any major changes there at all. And now when I go into my toolpath parameter, I have the following. I have my maximum step over. I'll change it into 2mm. And we'll also note that in our sorting, I'll keep it at zigzag. Now we'll go to our link area, and this area is actually very important. Remember I said that we have these problems over here with these surfaces that we have to jump over those surfaces. The way we deal with that is very simple. All we do is we have the area of gaps along cut. We go into our large gaps and simply say go directly from one surface to the other as seen in this picture on the side. Also on the slices, when we get at the end, the way we connect, we can also connect direct going from one slice to the next slice. Let me do a quick save and calculate. And if we take a look at our simulation, you'll note that the toolpath itself is going exactly across those slots as you've seen over here without even blinking an eyelid. In other words, it's going directly as if there was material over there. Now, one other thing I like to do here is I'd actually like to extend my toolpath to go past the part. For that, I can just simply go back into my geometry area, and we have a simple tool here called Extend and Trim. What I can do here is as follows. I can give it a value to extend it on either end of my start and at my end, and I'll extend it at this point 20mm so we can see exactly the extension that we've done on both the start and end. Now when I do save and calculate and run my simulation, you'll see that the toolpath now is going past the part itself, giving us for a smooth finish at the ends as well by passing over those edges. Now in this next part that we have on our screen, I'd like to demonstrate how we can work on these surfaces around over here, and I want to actually work parallel to these curves around the part itself. But in addition, I also would like to have control that my tool should not crash into these walls itself. I have complete control as to also the distance that I can actually go away from those walls itself. To show this, I'll start my option of HSS, and I'll use in HSS the option of parallel to curves. Now, in my geometry, my drive surface will be these surfaces as shown over here around the part itself. And my edge curve will be this curve along here. In other words, I'll be working on this surface parallel to this curve itself all around the part. Now, the tool that I will be using will be a ball and mill, a 6mm ball and mill. My levels I'll leave exactly the way it is. Now, in my toolpath parameters, I'll have my maximum step over of 2 millimeters. But now let me go into my sorting. Now in my sorting area, we saw before zigzag, and we also have the option of going one way, but we would like to now use the option of spiral. In other words, I'll be having a spiral cut on the part itself as shown on the picture as well. Now, let's go into my link area. In my link area, I would like to now have control of how I actually lead into the part and how I lead out of the part. So for my first entry, I'll use my lead in, and for my back to clearance area, I'll use my lead out. Now, in my default lead in and out, what I'll do is as follows. For my lead in, I would like to actually change this to vertical tangent arc, coming in from the top onto the part itself. However, my lead out, I'd actually like to do this tangential arc. But since my tangential arc will actually go on the surface itself, I like to pick it up a little bit from the surface so it doesn't leave a mark. For that, I can simply add the option of height as seen in this picture, and I'll add a height of 1 millimeter. Next, now we have to deal with our gouge check. If we machine this part right now the way it is, we'll actually be crashing into these walls itself. My tool path goes exactly up until those areas itself. So we have an extremely powerful tool in HSS, which is not available anywhere else, which actually checks the gouge, making sure it does not crash into the wall, and it can also keep it away a specific distance that I choose. I'll simply go into my gouge check, and we have a series of 4 different possibilities for gouge checking. In other words, for my first gouge check, for example, I'll use that, and I'll only have a gouge check on my drive surface. Now, in my drive surface, if I would see a gouge on my drive surface itself, I'm going to have my strategy of retracting along the tool axis, in this particular case, Z. Now, in my gouge 2, I would like to also use gouge, but in this particular case, I'd like to use a different retract option. First, I like to choose my check surfaces. Now, my check surfaces in this particular case will be these surfaces around the part over here, as shown on the part itself. Those are the surfaces that I'd like to make sure I do not gouge into, my check surfaces. Now, not only that, but I also have the option here of saying, okay, how far away do I want to stay from that? And I'll say, just so we can see it easily, I'll put in 1 millimeter. Now, I'll choose a different strategy for leaving the surface itself, and I'll use the option of leaving out gouge point. And at the bottom over here, I'll say, okay, let's leave out our gouge point from the last collision point itself. Now when I do save and calculate, and we look at our simulation, we'll see that the toolpath itself is going in a spiral fashion around the part itself. And let's take a look at you'll note that the toolpath stays 1 millimeter away from the wall itself. Not only that, we have our lead in and lead out. My lead in going in an arc as shown here vertically, and my lead out also going in an arc, but also leaving the surface going straight up by 1 millimeter. In this next part, we'd like to demonstrate the best way to work on the filleted areas. Now, this particular part was already machined beforehand in a 5-axis machine, but right now what we like to do is finish off the fillets themselves. Now, the best way, the best tool that we have and the only way to do it properly is within HSS using the morph between 2 curves option. That way I guarantee myself with the perfect finish on the radius itself. If I were to start my operation of HSS, we'll choose the option of morphed between curves. Now, in this particular case, I'll be using Mach 1 position 2. And in my geometry, I'll choose my surfaces, which are these surfaces as shown over here. And my curve, my start curve, will be my first contour of this area over here. In other words, I wanted to start off from that curve itself, and my end curve will be contour 1, which will be the bottom curve as shown over here. Now the tool that I will be using will be a 6mm ball and mill, and when I go to my levels area, I'll leave that exactly the way it is. Now in my toolpath parameters, I'll set my maximum step over to get a nice finish. I'll set it at 0.1 millimeters. Now in my sorting area, I'll leave that at zigzag since it's going back and forth on this curve itself. Now in my link area, I'll just change my link between slices to direct. Now if I do save and calculate, you'll see that in my simulation itself, the toolpath is going exactly on the curve itself, giving for a perfect finish on the fillet of the part itself. Now in this next part, I'd like to work on these surfaces around here on the part itself, but what I'd like to do is this time, instead of using morph to curves, I'd like to use the option of morph to surfaces. The reason for that is a lot of times it's a lot easier just simply picking the surfaces instead of picking the curves. And in this particular case, I'll be working from this set of surfaces over here and working down towards these surfaces down at the bottom. I'll start my operation of HSS and I'll choose the option of morphed between surfaces as shown over here. Now my geometry, my drive surface will be the surface shown over here. These surfaces around over here. And when I go down now to my start edge surface, I'll choose these surfaces on top over here, and my edge and my end edge surfaces will be these surfaces at the bottom as shown over here, going all the way around the part itself. Now the tool that I will be using will again be a ball and mill of 6mm, and in my toolpath parameters, I'll be using a maximum step over of 3mm with a strategy of sorting of zigzag. Now in my link area, I'll be using my lead in and my lead out, and also link between slices in my large moves, I'll have that as direct. Now in my default lead in, I'll be going in with a vertical tangent, but my lead out in this particular case will be a tangential arc. Now I'll run my calculation and then simulate. And in my simulation, you'll see that my toolpath is going down from the top, from this first shape on the top, and then gradually working in towards my second surfaces on the bottom as shown over here, giving for a smooth cut around the entire part. And that's the perfect way for this to be finished. And we can also see we have our leads in and exactly the lead out, exactly the way I had specified them. Now in this part, I like to demonstrate how I can machine these surfaces over here around the part the quickest and most efficient way of doing it. I'll start my operation and I'll use the option of HSS using the option of parallel cuts with constant Z, and in my geometry I choose my surface. Now the surface that I'll be choosing, what I want to do at the end is actually be all of these surfaces. But right now, I want to just pick these first two surfaces over here and work on those two only. Now, the tool that I will be using again will be a ball and mill of 6mm. And in my levels, I'll leave that exactly the way it is. My toolpath parameters, I'll change my maximum step over to 0.5mm, working zigzag on the part itself. In my link area, I'll choose lead in, and I'll also use my lead out for my part. Now I'll also go into my link between slices, and my large moves, I'll keep that as direct as well. Now when I do save and calculate and simulate the part, you'll see that my toolpath is working smoothly along the surface exactly the way I want it to work without missing any part of the surface itself. But what I like to do now is I like to add these surfaces and have this go directly from one side to the next instead of jumping up. So what I'll do is it's very simple. I'll go back into my geometry and I'll just simply add the other surfaces that I have to work on. This surface and this surface as well. As we see now, we have 4 surfaces. Now when I go into my link area, I'll make one change. That is because now I have a large gap over here. I'll change my large gap to direct, going directly from one area to the next. Now when I do save and calculate and simulate the part, you'll see that my toolpath itself is going directly from one edge to the other, exactly the way I had planned this to be done, giving me for a nice smooth cut around the part with my lead in and lead out as well. Now in this last part, we'd like to demonstrate how we work on a part where we have an undercut on the surface itself. If we take a look at this surface over here, this surface is actually undercut underneath this area over here. And the only way that this can be done is by using HSS. Now we'll start our HSS operation and we'll choose the option of morphed between curves. Now in my geometry, my drive surface will be these surfaces over here. I've chosen every single surface that's over here. These are the surfaces I want to go from this side all the way, including the area that's undercut as well. Now my first edge, my start edge curve, will be this curve as shown over here on the part over here, this curve over here, and my end edge curve will be the one on the other side of it right over here. My tool that I'll be using must be a tool that is actually able to go underneath that undercut area, and that tool itself is a lollipop tool as shown over here. This is the type of tool that can actually easily work on undercut areas. My toolpath parameters, I'll change my maximum step over to 0.2 millimeters, keeping the sorting at zigzag. Now in my links, I'll use my lead in and my lead out, and I'll change my link between slices to direct, to be able to go directly from one slice to the next. Now if I go into my default lead in and out, I'll choose the option of vertical tangent for both my lead in and lead out as well. Now when I do save and calculate, we'll take a look at our simulation, and you'll note that in my simulation the toolpaths is actually going around underneath the part, and you can see now over here how easily the tool simply goes out from the surface itself, giving a nice cut for the undercut part of the part itself. This concludes our demonstration of HSS, the high-speed surface machining module for smooth and powerful machining of localized surface areas in the part, including undercuts. Take care and have a nice day.